hello. So, here is a two-phase flip-flop design. This one right here. This is the two-phase flip-flop design. You can see the two clock signals. They need to be pulses, and both of them cannot be on at the same time, of course. They need to be independent signals. So, like that, and then this one, like so. Of course, if you have both of them in the same on at the same time, it will get it will go into an undefined state, and it will start flickering those. They will start flickering, and that's bad. So don't do that. One at a time. On, off, then on, off. Right. Now, the interesting thing about this flip-flop design is that it can be expanded up to two flip-flops chained together to make a 2-bit binary counter. So there's the lowest binary digit, and here's the higher binary digit. Now the blocks you can see here are white lights, so yeah, light stones in the Mesecons mod. I have customized the texture myself. That is not the vanilla texture for this mod. This is my own custom texture for it because I think it's better this way. I customized that myself, but whatever, who cares about that? Ignore this stuff here. This one I was testing whether I can expand the counter further, but as it turns out, it can only go as high as 2 bits. So 2 bits only. So this and this are identical. So you can see here the structure, this thing, and this thing. This is logically the same. This is the same thing as this one. The wiring is just different. Yeah, the ones here didn't work. I tried to make a counter out of it, but it only goes as far as 2 bits. The design won't allow any further. It works only as far as 2 bits. Yeah. Now, the interesting thing about this thing is, and what I'm gonna be telling you is that, well, if you want to go higher and you want to have a counter that counts more than just 2 bits, then I have already made a previous video where I show you this 3-phase counter, and I have added some of my own stuff to it. Yeah, this stuff isn't in the video, in the previous video. This is my own stuff that I'm gonna do in my own builds. That's not necessarily relevant to this video, but anyway, this design here that changes over time as I design it further. Yeah, that's the 3-phase count. That's the 3-phase flip-flop counter. So that counts up to as far as you want to take it. You can expand this counter, this 3-phase flip-flop counter. You can expand that up to infinity, but this one only goes as far as 2 bits. So what if you only have 2 clock signals and you want to count up to infinity? So you can see here 0, 0. Ignore the other ones. I should destroy those anyway. Not confuse anyone. They are not necessary. So anyway, here you can see 0, 1, 1, 0, 1, 1, 0, 0. Oh, and by the way, it doesn't matter how many times you click the same one. If you keep hitting at the same one, it doesn't matter. It's the same thing as just having the thing on continuously. As long as it goes on and off, whatever happens in the middle doesn't matter. And then after that, this one has to go on and off, on and off, on and off. Yeah, whatever, if it goes on twice or 3 times, that doesn't matter. That doesn't change anything. Anyway, that's 2 bits. Well, the convenient thing about having 2 bits, 2 binary digits count up like this, is that you can take the signals and take it into an unary decoder, and here you have 4 signals then. So you might have noticed, as I've been counting up these things you can see there, it's actually, well, that's a visual delay. The delay thing is visual. Anyway, oh yeah, I also mentioned this one, this left one, you might have already noticed. It's the left one that triggers the change in these digits, and then the right one only does an internal switch, so those stay the same, and that doesn't change anything on the lights. Those lights don't change, but this thing switches the lights, and this is the stable period when the lights stay the way they are, and then this thing happens in the stable period. So as it happens, when there's a stable period, when that happens, you can see how then when it is in the stable period, that's the stable period, and you can see how it does that. So you can see these are 0, 0. So while it is in that state, in the stable period, those two remain the same. This clock signal only does an internal switch, so therefore it doesn't affect those lights. So therefore this can be used to get a pulse out of that. And you can see the unary decoder, it takes those there. Right. So now this does the switch, so now that updates, and then that one changes, and now it changes that one. So now, as you can see, as I'm hitting these like so, that thing counts like that. And you know what that thing is? Well, that's 4 consecutive clock pulses on their own wires. Well, as it happens, you could just take a wire out of these 3, and you could just take those 3 wires and hook that up to this counter that can count up to infinity. You can see how it counts there. I've already seen this in an earlier video, or you can go see that if you haven't seen it already. Yeah, that's a counter. Yeah, that's a counter. So these signals, you can then take these 3 there and just ignore the 4th one, or you can use it for something else. These 3 can be used to make into a 3-phase flip-flop counter. So this way you can get counters up to infinity from only 2 clock pulse signals. So 2 clock signals, clock pulses on their wires. You can use this 2-phase flip-flop design. It can be stacked up to 2 bits of output in a counter, and you can see that the wire that turns this on gets used here for the clock signals. The clock signals go straight to this one, but here they use the output of that previous flip-flop to allow the clock signals in. So you can see that the clock signal coming from there goes there, and then this output allows that there. This is just the wire that goes there. So yeah, this is that thing. This one didn't forget. These ones didn't work, so forget about them. And then, yeah, well, basically this is the design. Like I said, this one and this one are logically the same. Yeah, these are basically the same thing. So the wiring is just different. So you can basically copy the wiring from this one and design both of these the same way. Anyway, that's pretty cool. You can get 3 clock signals, 3 pulses, and then you can just take the wires here to this place, like this. And then that's a counter. And now you have a counter out of 2 clock signals. If you for some reason cannot have 3 clock signals, or if you just want the flip-flop for some reason, you can do it with this design, or with these wires. You know, it's the same thing, just different wiring. I also mentioned, well, you can see that this is a NOT gate, but here is a whatever this one thing was called, NOR gate. Yeah, well, there's actually no reason for it that other than that thing just takes the input from the side. You know, you can see this is a NOR gate. It's supposed to have 2 inputs, one from the left and the other from the right, but I only populated the left one because, well, I don't really need anything on the right. But it still works as a NOT gate. I mean, this is basically just a NOT gate, but the thing about NOT gates is that you would then have the wire go there. I mean, I guess I could do that, right? I could take that wire like this and hook that up like so. Yeah, that's the thing. That's a thing. I could do that. Yeah, I could do that. That works the same. Yeah, you can see it works the same. Yeah, that's probably less confusing. It's probably bad to do anyway using these. But I mean, I just use it because it takes it from the side. Yeah, there's really no other reason for it. I just use it because it's from the side. Because if I had it coming from the bottom, then I would need to take the wire further like that, and that's just inconvenient. So, whatever. Yeah, here also I could just make this into a NOT gate. That could be made into a NOT gate, just move this wire that way. So basically the same thing. Well, I could just do it for the sake of consistency. Yeah, I move that wire. Let's see. This one. Let's see if I should do that. What if I do it like this? Wait, what's supposed to be a turn? Yeah, I'll do it like that. Anyway, that's the same thing now. Wait, is that the right way? Yeah, it is. It's pretty dangerous if you do them both at the same time, because... Well, actually, I'm gonna show you what happens if we do them at the same time. This happens. You can see how they flicker like that. Oh yeah, and that one broke. Yeah. So, don't do it like that. Don't have them on at the same time. That's dangerous. So yeah, take your time between these buttons. One, the other. One, pause, the other. Yeah, you take a pause between those two like that. Anyway, well, that's that. I guess there's not really much else to this thing. Yeah, 2 bits, only 2 bits. I tried to make it further, but it didn't work. This design, it might be impossible to expand that to infinity. It might only work as far as 2 bits. But 2 bits is enough to make a unary decoder with 4 values, and 4 can be... Well, you can ignore the false one and just take the 3 first ones and take the 3 first ones to this 3-phase flip-flop, and then the 3-phase flip-flop can be used to make a counter. So you can basically just put these 2 and that thing ahead of this structure right there, and then you can have a counter with only 2 clock pulse signals. Yeah, like I said, ignore that stuff. That's just my own stuff for my own purposes, not relevant to the video. Right, so that's that for this video.